Hello everyone. Let's continue on the next topic of chapter 3, which is we are on the normal random variable, a normal distribution, and the next topic is about finding the z-scores from the known area. Before this, we did finding the probability of the standard normal random variables. See, we did this one, finding the probability, which is the area under the curve, and we use the table for standard normal distribution or standard normal random variable here. For z-score, we use SAT to stand for standard normal variable. Okay, now the next topic, it's something might be the inverse or the we are looking for here. Before this, we're looking for the probability, which is the area, given that for a given z-score. Okay, and we look in the table, we look for the z-score, and then we look for the area, which is corresponding to that z-score. So the next topic is to find the z-score when you know the area. Okay, it's just the inverse of that. If you know the probability or the area under the curve, okay, if you know the probability, if the probability is given, and we need to look for z-score, which is corresponding to that probability, we can do it as well. Let's see. Okay, if this area is given, and what we are looking for is we're looking for the value of a right here, looking for this value. What z-score that gives you the area? For example, we are looking for the z-score that gives you the area of 0.95 here. How are we going to use the table to find that? Because the table is the opposite. The table is finding inside the table is the probability for a given z-score. Okay, so here is the steps. If the probability area falls between the two z value, okay, then usually we use the interpolation to approximate the z-score, but since we are not like precise, we don't need the precise value like that, we can, for this class, for simplicity, we will use just an estimation. So actually for a given area, we will choose the z value that has the area closer to the given area. Okay, we just need to approximate it. So you go look up in the table, look at the value and see which value, which probability that is close to the area given or the probability given. Then you use that probability and go look back for the z-score. Okay, and we also have the common or spatial probability right here for example here, bell-shaped curve. So for example, for the z-score, this is 0 for 1.645 here. Okay, the z-score 1.645 gives you the area of 0.95. This is the spatial probability, which means this is 95%. Okay, or if you look at the z-score of minus 1.645, minus mean the z-score which is on to the left of 0. Okay, 0 is in the middle. We are working with the standard normal distribution. So the mean is 0 and the standard deviation is 1. Okay, so if z-score is minus 1.645, the area, the probability here is 0.05 or just 5%. Sorry, 5%. Oops, that's too big. So the area here, it is just 5%, okay, or 0.05. And you can look at the other values too. We have 95%, 5%, 99.5, and 0.5%. This is 0.5%, 95%, 5%, and 99.5% for the probability. This is 99.99. Okay, so other than this, you need to use the table, okay, to approximate it. Let's see how to do it. For example, right here, this example 2, find the value of A such that P of Z. Okay, we are looking for the value of A. Okay, the value of A here. What is this value? So that the area here is 0.8770. All right. So we look in the table. Okay. From the table, do we have the table here? 0.8770. So you look inside the table. Remember, inside the value inside the table is a probability, and outside here is z value. Okay, so we're looking for the value, what, 0.8770. Is it in the table? Let's put it right here, 8770. So go look in the table. The z value, the corresponding z value is 1.16, right? So from the table we know that since P of Z less than, what is it again, 1.16 is equal to 0.8770. Therefore, so that we have A equals to 1.16. So if the value show up in the table, it's not hard, it's easy. But if the value is not in the table, we need to do approximation. Well, we will not get the exact value because we need interpolation for that. You need to compare and a lot of work. So we just for this class we just need an estimation. For example, the second one, part B, looking for the value of A such that P of Z less than or equal to A. The probability of this is 0.0125. Go look at the table. 0.0125 is less than 0.5, so it must be the z-score with negative z-score, right? It's to the left, okay, to the left, the other half, okay. So that means we're looking for the negative z-score, and 0.0125, let's see, 0.0125 0, 1, 2, 5. Where is it at? Oh, it's here. Between these two values, right? Between these two values. So it's gonna be between minus 2.24 and minus 2.25. 2.24 and 2.25. This is 0.225. Okay. So since the probability of Z less than, well, with equal sign or not equal sign, it is the same. Minus 2.2 what? 25. 24 equals 0.0126, right? And P of Z less than or equal to minus 2. Oh, let me fix my writing. Z less than or equal to minus 2.25 is equal to 0.0122. Okay, so 0.0125 lies between these two values. And since it is closer to this value, right? Closer to this value than the other value, than 122. So I can use the first one, okay, for the Z-score. Okay, so we choose A equals to minus 24 because the area 0.0125 is closer to 0.0126, okay, than 0.122, right? So we choose the area which is closer to the given area, and we read the Z-score from according to that area. So the answer is minus 2.24. So this is the answer. All right, let's see, take a look at part C. Part C, we are looking for probability of Z greater than A, which is equal to 0.025. Okay, we go take a look at this. And since we don't have the table for greater than, we are looking for the value of A, so that the probability at the tail is 0.25. So we're looking for this, which is the same thing as we need to convert it to the other side. So that means we need to convert it, okay, to the other side. So P of Z greater than A is 0.025 is the same thing as P of Z less than A equals to 1 minus 0.025, right? So we need to convert to this area. So this is gonna be the opposite because the whole thing is 1. So minus this, you get what? 0.975. So we are actually looking for A such that P of Z less than A is 0.975. So go check in the table. Okay, go look in the table. 0.975. Do we have it in the table? Otherwise we need to approximate it. 975 right here. We have it. We do have it. So the z-score is 1.96. Okay, z-score is 1.96. Go back. Since p of z less than 1.96 is equal to 0.975. Okay, so we have a equals 1.96, like that. All right, so part D is the area in the middle. So we need to think a little bit. It's the area in the middle. Let's take a look. We are looking for A. Remember the area A and minus A, they are symmetric, about 0. Okay, so actually we are looking for the A value. The graph is symmetric. So if A is here, minus A is here, reflect over the middle, which is the mean. Okay, the mean is 0. Okay, so we're looking for A such that the area in the middle is 0.99. Okay, this is challenging. So since we have the table only like from the negative side all the way to A, so we need to think a little bit. We need to think of the area, the white area, the missing piece. Okay, what we are looking for is we need to look for the area here, so we can figure out A. Okay, the whole area here. From here we need to fill in the piece, these two little pieces here. We need to know the area of these two, since the whole thing is 1, so that the two pieces at the tail, the area of these two pieces will be 1 minus 0.99, right? The combination of these two areas, which is gonna be 0.01. So if I look at only let's say the green area, so just only one piece, okay, so that the green area must be half of this, because 0.01 is a combination of the two tails, two left and right tails. So you need to split this into half to get just only one piece, and which is going to be 0.005. So the green area is actually 0.005. Okay, just one piece of green area, which is the same thing as the area here. So you need to add the two pieces together, which is the blue piece 0.99 and the green piece. Okay, so add them together. So the total area up to A, this area, oops, this area up to A, it's gonna be the combination of the two. So the whole area here, it's gonna be 0.005 plus 0.99, which is 0.995. Okay, this is 0.995. Actually, we can, that means we are looking for the value A such that P of Z less than A equals 0.995, or you can actually look at just the other way, P of Z less than minus A equals 0.005. This works as well. We give the same A. Okay. Now let's take a look at this. I'm going to use the first one. We look at in the table. Okay. For 995. 995. Oh, right here between these two values. Okay, between these two values. So Z being 2.57 and 2.58. So 9950 lies between these two values. All right, since, oops, I hit the wrong button. Go back. So since from the table, we have that P of Z less than 2.57 equals 0.9949, and we also have P of Z less than 2.588 equals 0.9951. So 0.9950 lies between these two values. So we can use either 2.57 or 2.58. So we can use either 2.57 or 2.58. However, since we know that 50 it's in like midway between these two values, so it's not bad to find the halfway between these two values, right? So however, it's just halfway, so let's do it. However, the probability is halfway between these two values. So I know that my A is just halfway between 2.57 and 2.58, so it's just 2.5575, right? Just halfway. Or you can use either values. I'm fine with it. Okay. All right. So this is the way to find just the converse of what we found earlier. So given the probability or the area, and we are looking for the C value. Okay, here we just need to estimate it. All right. Let's move on to the next one. This is the table. I will give you the table. So, so far we have done, completed the probability of the standard normal distribution. Now, for the non-standard normal distribution, non-standard means the mean is not 0, and the variance or the standard deviation is not 1, right? For the regular normal distribution in general, how to find the probability? Let's see how to find it, because the table it's provided for only standard normal distribution. So for any normal random variable x, we can standardize, okay. From non-standard, we can standardize the variable x, okay, or transform x. We call it standardize, transform x into the standard form. Okay, so from x, x, which is random variable, normal random variable with mean, mu, and variance, sigma squared. You can transform or standardize, okay, transform to standard normal distribution with the mean being 0 and the variance being 1. Okay, you can do it, you can transform it with the formula using the following formula. Z equals x minus mu over sigma. So Z is from standard normal random variable for Z, and x is a non-standard one. So you can change from non-standard to standard and go back and use the table. Use the table to find the probability. Okay. So the first step you need to do is to convert it to the standard form, and then you can use the same table that we did before. Let's see example. Okay. Example 3. Let x be a normal random variable, just any normal random variable with non-standard, with mean 10, and here they give the standard deviation sigma. So either sigma square or sigma is fine. Just give one of those value, okay, but you need to write down which one is which. Okay, so find in this problem we need to find p of x less than 14. So it is not Z anymore. It is not standard normal distribution or normal random variable. In this case, mu is 10, and they give you sigma, which is 2.5. So in this case, we need to transform x to Z, okay, by using the formula. Little z is x minus mu over sigma. Okay, in this case, x follow normal distribution with mean equals 10, and sigma, see, write down like this so you know it is sigma, or either it is a variance. Okay, so use this formula to transform it. Part A, we are looking for probability of x less than 14, which is non-standard form. So we need to standardize it using the formula. Change x to z, but to change this, we need to let me write it down. Write this down. From x to z, this is the little x value, right? From x to z, we need to do subtract x minus subtract mu, which is 10, over sigma, which is 2.5. So up there, p of x less than 14, we convert it, we transform it to z. So it's gonna be p of z less than x minus mu. This is x, this is mu, and down here is sigma. Okay, so if you convert to z, then you need to subtract x by mu and divide it by sigma to get the z value. Okay, and then need to calculate this value. So from x less than 14, it's gonna be equal to, see, less than, what is it, 4 over 2.5 give you 1.6. So look in the table. From the table, check in the table. 1.6 is table around here. 1.6, 1.6, 1.60, 9452, right? 9452. So from the table, P of SAT less than 1.6 is 0.9452. This is from the table, and the answer is just that. Okay, but we need to transform it. Part B, looking for P of X greater than 8, less than or equal to 14, with equal sign or not, they are the same. So transform it. We need to transform it to SAT by subtracting the mean out and divided by standard deviation. See, and from X have to change to Z. If you normalize, standardize it, then the variable have to change from X to Z or Z. So 14 minus 10 over 2.5, which is we are looking for P of minus 0.8 less than Z less than or equal to 1.6 again. This piece is in the middle. What we did before, it's gonna be between Z less than or equals to 1.6 minus P of Z less than minus 0.8, right? Go look in the table. Yeah, it's in part A. This is 0.9452, and for Z less than minus 0.8, from the table the probability is 0.2119. Subtract these two value out. Remember, probability cannot be negative. If you get negative value, then there is something wrong in your work. Go check your work. So we get the answer here. Alright, not bad, right? You need to standardize it. Part example 4. Okay, let's see. The monthly salaries of the workers at the factory are normally distributed with mean of 210 and standard deviation of 10 pounds. Okay, sterling pounds. This is the salary. Okay, we have mean of 210 and standard deviation of 10. We need to find what? Determine the probability of choosing at random, choosing randomly, choosing what? A worker with salary between 184 and 233. We need to find probability of this, that you choose a worker and the salary of that worker lies between 184 and 233 pounds. Find the probability of this. So from here, it is already given that it is a normal random variable. So let X, I'm gonna write down X here, X be the monthly salary of the worker at the factory. Okay, so X follows normal distribution with mean 210 and standard deviation of 10. Okay, now what we need to look for is finding probability of X greater than 184 and less than 233. Okay, so set this up. P of X greater than big X, X being random variable, so big X greater than 184, less than 223. Convert this, standardize this by subtracting from X. We don't have table for X, but we do have table for the z-score, so need to convert it. Minus mu over sigma less than z less than 223 33, sorry, 233 minus 210 over 10. Okay, so calculate this, get minus 2.6 less than z less than 2.3. Again, this is a piece in the middle, so it is from P of Z P of Z less than 2.3 minus P of Z. I need to erase this. Less than minus 2.6. Okay, so open up the table, go look in the table. Where is the table? 2.3 and minus 2.6. Table is not here. Never mind. Okay, go look in the table and you figure out the value. This is 0.9893, and in the table for P of Z less than minus 2.6 is 0.0047. You subtract these two values, you get 0.9846. Okay, this is the answer. The chance that that person will get the salary between 184 to 233 pounds is about 98%. Okay. Next, let's see. Example 5. In a school with 1,000 students, the height of students are normally distributed with mean. Okay, mean is 113 centimeters and standard deviation 5 centimeters. Okay, so X follow normal distribution, or X is normally distributed with mean 113 and sigma. If they give you variance, then you need to take a square root of that to get the standard deviation. So find the probability that randomly chosen student is shorter than 121. So part A, we're looking for P of X less than 121, right? And part B, how many students are shorter than 121? We need to think more. So after we get the probability out, then we need to think more, like convert that to number of students. Okay, let's do part A first. P of X less than 121. So this is not a standard normal distribution. So we need to convert it to Z by subtracting the mean out. Okay, subtracting this by mean over the standard deviation 5. Okay, so P of Z less than, calculate that, you get 1.6. Open up the table. 1.6, we did that before. Open up the table, 1.6, then you get the value out. Let me see, keep the ink. So 1.6, we did that before. 1.6 is here, 9452. So 9452, go back to that problem. Point, oops. Point 9452. So the probability is 0.9452 that a student, if you choose a student and that person will be shorter than 121 with a chance of 94%. So part B, we use that to find part B. Asking for a number of students which are shorter than 121. So from part A, we know that 94.52% are of the student are shorter than 121 centimeters. Okay, so from here, since we know that the total number of students, we have 1,000 students, right? So we take 94.52% of this, then we will get the number of students out. Okay, therefore 94%, oops, 94.52% of 1,000 students equals percent means out of 100. So 94.52 over 100 times 1,000, right? 1,000 students. So this gives you 945.2. So we write it down because number of students. Therefore, there are about 945 students who are shorter than 121 centimeters. All right, so finish example 5. Let's see the next one. Example 6. Assume that the IQ scores are normally distributed with a mean of 100 and standard deviation of 15. So looking for what is the IQ score that separates the IQ scores of the lowest 25% from the rest. If you look in the picture here, so we are looking for the IQ score, which is the X value. We're looking for the X value. Since we know that 25% is less than 50 and 50 is in the middle, right? So this must be a Z score with negative value. But for random variable with X, might not be negative, right? But for Z score, it's negative for sure because it's to the left of 0. So we're looking for this number X, not Z. We're looking for this number X so that the area here is 0.25. Okay, the area here is 0.25, right? So IQ score of the lowest 25%. So we're looking for that. write everything down. We know that x is normally distributed with mean 100 and sigma of 15. Okay, write down like this. And we know that we need to convert with this formula. The little z is equals to the little x minus mu over sigma. So what are we finding? We find value a such that, okay, p of x less than a is being 0.25, right? We need to look for this value, x or a, x equals a here, okay? We need to look for a, okay? Let me change it to a so you don't get confused. Looking for a here. Now, we need to change to z, right? It's gonna be complicated here. From here, from the table, okay, let's look at the table. We might do something opposite. P of x less than a, go look in the table. Go look in the table. Go save this, keep the ink, and go look in the table. We're looking for 0.25. 0.25, where is it at? 0.25, 0.25, it's about 0.25, closer to this one maybe. So 0.25 lies between, where is it at? These two value. So it is closer to this one, right? 5.4 is closer to 0.25 than 0.2483. You can check it out. So I'm gonna use the value 0.67, okay, for this one. Let's take a look at that example. Okay, from here, the way to write down might be different from the previous example. From here, since we are looking for the value of a, not the area, it's the other way around, so we need to work out from the area back into the x score or z score, okay? From here, we need to work out from the area first from the table. We know that p of z less than minus 67 is equal to, it's approximate, okay? Approximate value of that, we approximate the area, which is closer to 0.5, right? So we approximate it, and we use the value of minus 0.67, which is closer to 0.25 than the other value. So from the table, we know this. So compare, we need to compare this, the inside here, okay? From here, we know that z is gonna be 0.067. So we use this value, z equals to x minus mu. So we know that 0.67 must be equals to a minus 100 over sigma. Here I'm using the formula z equals x minus mu over sigma to compare the value. So you compare these two values and need to work out the value for a, do the math, okay? So we have a minus 100 over, sigma. Sigma, we know the value. Sigma is 15, right? So a minus 100 over 15 is minus 0.67. So multiply both sides by 15. We have a minus 100 equals to minus 67 times 15. So a is going to be, you times this value out, minus 0.67 times 15, you add both sides by 100. Then you have a equals, actually 100 minus these two values, if you multiply them, you get 10.05. So a is going to be 89.95. That means the IQ score is 89.95. That's the answer. Here you need to work out the area first, and then you compare with the formula to get the value of x, the little x, and I name it a for this one. Okay, this is the little x that we are looking for. All right, this is the other type of the problem. Okay, and I think the last one, example 7 is the last one. Let's see. The U.S. Air Force requires that the pilots have the height between 64 inches and 77 inches. In the U.S., we use inches and feet, right? Find the percentage of the men meeting the height requirement. So we need to looking for the percentage of the men meeting the requirement here. Okay, the pilot requirement. From here, I forgot to set a previous example. The IQ score, I forgot to set it as x, sorry. So here, the U.S. Air Force require the pilot's height, right? So x, it's going to be the pilot's height. Okay, let x be pilot. Okay, so x is normally distributed with mean. Forgot to give the mean. Oh, in this problem, forgot to give the mean. I think something is missing. Find the percentage. Okay, given that oops, I cannot write down. The mean height is, the question is missing. 68.6 and standard deviation is 2.8. Okay, so given that mean is 68.6 and sigma is 2.8. I think I accidentally deleted it. So we are looking for the percentage, right? Percentage means the same thing as probability, and you multiply by 100. So we are looking, first step, we're looking for probability of x that lies between 64 and 77. Okay, find this one. So this is non-standard normal random variable, so we need to standardize it. So p of x greater than 64 and less than 77 equals, transform this, subtract mean 68.6 divided by 2.8, and change the variable from x to z, less than 77 minus 68.6 over 2.8. Calculate the value. P, this is minus 0.64, less than z, less than 3. This is the p's in between, so this is p gonna be p of z less than 3 minus p of z less than minus 1.64. Calculate the value out. Open up the table. So from the table, z less than 3 3.0 is this value, and minus 1.64 minus 1.64 0.0505. Okay, so from here sub this value in, 0.99887 minus 0.0505. Subtract these two values out, you get 0.9482, and convert this into percentage. So the percentage of men meeting the height requirement is going to be 0.9482 times 100. So convert this into percentage, it will be 94.82%. That's it. This is the answer. Okay, all of the applications I think are covered, and you guys can try to practice this example. I put the answer already here, so try to practice on this, and you might make you understand better. All right, we finish. I will end chapter 3 here, and thank you everyone for this extra clip, and also don't forget to watch the beginning or the first half of chapter 4. All right, see you in class. Thank you.